Hello. Today's lesson is functions defined as an integral, which we talked about on one of our other lessons. Okay, so let's talk about this. A definite integral. This integral right here, you're integrating from a to b. Got function f, whoop, goes from a to b. When you integrate, you're accumulating all the stuff underneath and you end up with the area. This one, you're graphing. The graph is the derivative. Okay, this is little f of t. And we start at a, and the value of function f depends on how far you integrate. All right, I might integrate to 4, I might integrate to 6, I might integrate to 7. Okay, so f of t is equal to that much, or it's going to be that much, or it's going to be that much. So that represents the value of f. Okay, we did this on that one worksheet. I don't remember which one it was. What you end up doing is find the antiderivative of the cosine, which is sine. Well, we're using the second fundamental theorem, and you put that in here. Oh, no, we're not. Sorry, take that back. We're not taking the derivative. We're just evaluating the function. Okay, and we're going to evaluate it from 0 to pi over 6, and we're going to do the sine of x from 0 to pi over 3, and we're going to do the sine of x from, x, 0 to pi over 2. And from your unit circle, you know the sine of pi over 6 is a half, and minus the sine of 0, well, the sine of 0 is 0, so there's your answer. Pi over 3 is root 3 over 2, and pi over 2 is 1. And you're always subtracting 0, so there's your answer. Okay, so now we've got the function g of x. It's defined as the integral of f from 0 to x. So if I want to find g of 2, I'm going to integrate from 0 to 2 f of x dx. F of t dt. So I start here, I integrate over to 2, and it's that area. Well, this is 2 and that's 3, so be careful. 2 times 3 and a half equals 1/2. 2 times 3, which is 3. All right, if I integrate from 0 to 4, oh, I changed colors, darn it. That's okay. We'll do this again. Green. Okay, 0 to 4. Well, this is 3 by 1. This is negative 3 by 1. So this part and this part cancel each other out. And the answer is 3 again. Well, that was peachy. And then if I integrate from 0 to negative 2, remember I'm going backwards. All right, usually when you go backwards, it's negative. This is 2 by 3. This is f of t dt. So it's 1/2 of 2 by 3. But this is negative area, and then you're going backwards, so it's negative, and you end up with a positive 3 also. Because you're integrating in that direction, but it's below the x-axis, so it ends up being positive. Ooh, that hurts your head. Think about that one. Okay, oh, something on my iPad. All right. What intervals is g? Remember, that's this function. This function, when is it increasing? Well, this is the derivative of that. F is the derivative of g, so if the function's increasing, the derivative has to be positive. So it's positive from, let's get rid of all that stuff. 1, 2, 3, it's positive from 0 to 3. It's 3, 4, 5, 6, 7, and then 7 to 9. Because f of t is greater than 0. There's my justification. Values on negative 2 to 9, where it has a relative minimum. A minimum, it changes, right? It's negative to positive, so negative to positive. Remember, this is the derivative. So at x equals 0, and at x equals 7. What's the absolute maximum value on the interval from 2 to 9? Well, if you start here, this is 3, and this is 3. Oh, that gives you 6. All right, because this was positive 3, and 3 is 6. And these guys cross out, so I'm at 6. And then this is going to be 1, 2, 3, 3, half of that. So it's minus 9 over 2. And then we're going to add 2 by 2. That's 4, that's 2. So 6 minus 4.5 is what? 1.5 plus 2 equals 3. Well, that's interesting. I don't think that's what I had in my notes. Whew. Alrighty. On what intervals is g concave down? It's concave down when the derivative is decreasing. So my derivative decreases from 2 to 4. And with this, so what do we say? F of t is decreasing. Write an equation for the line tangent to the graph at x equals 2. Well, the slope, right, g prime at 2, you read right off the graph because this is the derivative, so that's 3. G of 2 is the area. We got to clean this up again. I got it messy. I do that a lot. All right, so G of 2 is 1, 2, 3, 6 is 3. And x is equal to 2. So now you've got y minus 3 equals 3 times x minus 2. Well, that's fun. Alrighty, we can do it again. Oh, first thing I did on this is found all these things. That's 2, so that you have pi r squared over 2. R is 2, it's 4, so this is 2 pi. Let's do this. It's 3 by 2 is 6, so that's 3. And this is 1, 2, 3 by 3, so that's 9 halves. And this is a half. And this is 1, 2, 3 by 1, so that's 3 halves. All right. So we've got, excuse me, we've got g of x. It starts at 3. So to find g of 10, you only go from here to here. So I add g of 10 is equal to 2 pi plus 3 halves. And g of negative 3, I'm going that way. So this is 3 plus 4.5 is what? 7.5. But it's going backwards, so it's negative 7.5 plus a half is negative 7. Well, that's a good answer. All right, now they want to find g prime at negative 1. That you read off the graph. G prime at negative 1. Read off graph. So it equals what? Negative 1 maybe? Sure, 1. G double prime is the slope at negative 1. So let's see, that rise was from negative 1 to 3, so that's 4 and 4, so that's 1. That's the slope. On what intervals is G increasing? Increasing, F has to be positive, so it's from negative 2 to 10, and it decreases from negative 3 to 2, negative 2. On the interval from negative 3 to 10, any x values where G has a relative minimum or a maximum. A relative minimum, min changes from negative to positive, so that'd be at negative 2. And a max, none. It never changes, okay? Find the absolute max. Oh, that's interesting. We go this way. So this was negative 7. Those are all negative, and this is all negative values. So we'd only go this way. The maximum value would be 2 pi plus 3 over 2. Values where it has a point of inflection. That's when your second derivative 0 or undefined. It's 0 or undefined here and here. So x equals 1 and x equals 5. Okay. it says G double prime equals 0 or does not exist. Find the intervals where the graph is concave down. That's when f of t is decreasing. So when's it decreasing? 1 to 3 and 5 to 7. Alrighty, so it's sort of information you've known before. You're reading a graph of a derivative. Okay, that's the derivative graph. The thing we've added to our knowledge is the fact that you're integrating and you're accumulating area along with taking care of increasing, decreasing concavity, points of inflection, etc.